cos squared x.
Sorry, say that again, sorry.
Sine squared x plus cos squared x.
Is equals to 1.
Yes. So that one, divide everything by cos squared x. What do you get?
You get sine squared x equals to 1 over cos squared x. Oh, no, sorry. Divide every... So would that just be... Oh, that would be sine squared x over cos squared x plus 1 equals to 1 over cos squared x.
Yep. And try to write each of them as one thing, like what is 1 over cos squared x? What is sine squared x over cos squared x?
End up being sine squared x plus 1 equals to... what's it? It was like cosec x. Oh, no, sorry. Sec x.
So that one's sec squared x. And what is sine over cos?
Tan squared x.
Yeah. So tan squared x. And same thing, except this time divide everything by sine squared x.
So now it'll be 1 plus 1 over tan squared x.
And what is 1 over tan squared x?
Cotan x
Yeah.
equals to cosec x squared x.
Well done. And so those were the two things that we had to prove, and we have proven them. And so if you ever have to prove those, just go back to your sine squared x plus cos squared x is identical to 1. Either divide everything by cos squared x or divide everything by sine squared x. If you have to get tan, then it would be, cos squared x is on the bottom. If you're not sure, just do both. And sometimes they'll write them differently, like tan squared x is identical to sec squared x minus 1. You'll just have to bring the 1 over different things.
Yeah.
Okay. That's what they are. This one. Is this what we're doing next? Okay. Hang on. Let's do this one next. Any idea about this? And actually, let me keep this little thing. These identities. I'll keep those. Okay. Whew. Any idea how we go about this?
So cosec 4 theta, would I have to write that like 1 over sine 4 theta?
This is very tricky. There's something that will help from the start. You may not see it. Let me just say, nah. Okay. Another way to write this one would be cosec squared theta squared. So like squared 2 times 2 would be 4. And then this one, same thing. This is a very kind of special one. Notice anything there?
So would that be like 1 over sine squared theta squared, or?
Yes. Before we do that, however, what if I did this? A squared minus b squared. Any idea about what that's about?
So does that mean that cosec squared theta is equals to a, or?
Yeah. So I just let it be equal to A, let it be equal to b. Anything you notice about a squared minus b squared?
Would it be equals to c squared or something, or?
No. What if I wrote it as 9? No, what if I wrote it as x squared minus 9?
Do you is that factorized or something like?
How would you factorize it?
Would that be like x minus 3, x plus 3?
Yes, and that's because 9 is 3 squared. And so we have something squared minus something else squared. What would that be?
Uh, so I now need to factorize out these two.
So yeah, factorize. What would it be?
Cosec. Would it just be cosec theta and then cosec theta square, cosec theta, or
You could just leave it as cosec squared theta. Do the A and B one.
so would that be a and then like minus b and then a plus b, or
Yeah. And A was the same as cosec squared theta. So that would be
oh, so
cosec.
because it's a minus cot squared theta
Yeah.
and cosec squared theta plus cot squared theta.
Theta plus cot squared theta. Okay, I think that's how we go about this one. We're trying to change everything into cos. Okay, how do we go about that?
Should we now change everything to sine and tan?
Yeah, I think even eventually everything to sine and cos.
So do I now need to do 1 over sine squared theta
Yeah,
minus 1 over tan squared theta?
and I would change it into sine and cos right away.
So would that be minus cos squared theta over tan squared theta?
Yeah, I'm just going to clean that up a bit. So cos squared theta over sine squared theta.
And then the same. Oh, but just plus this time.
Yes. Okay, what is next?
So I'm guessing I now need to somehow get equals to 1 with one of these answers.
I'm not sure. I see two fractions with a common denominator.
Yeah, so that would become 1 minus cos squared theta over sine squared theta.
Yeah.
Oh, and that'll be times by 1 plus cos squared theta over sine squared theta.
Yeah.
And we know that and so isn't sine squared theta equals to 1 minus cos squared theta?
Yeah.
So that will then become and that'll become 1
Yeah.
times that'll just become 1 times 1 plus cos squared theta over 1 minus cos squared theta.
Yeah.
And that'll give us the answer.
That gives us the answer. So this one, very difficult to spot. That to the power of 4 is just squared squared. Minus sign in the middle. Something squared minus something squared is difference of two squares. And so we changed it into two things with a minus into like two fractions times. What else? And this general method that I just happened upon in our previous lesson, changing everything into sine and cos, even if it's 1 over sine, 1 over cos, just seems to always work. Okay, so seems totally different, or I don't even know. But part B, how do we do this one?
So, do I now need to do something like brackets sec squared theta, or even sec theta plus cos theta, and then sec theta minus cos theta.
It might be sec theta plus cos theta, sec theta minus cos theta. Okay.
And then do I now? Oh, actually, so should I replace like the causes with 1 minus sine squared theta?
Cos that would be cos squared theta.
Oh yeah. So should I have just initially not factorized it and just done sec squared theta minus 1 minus sine squared theta?
Perhaps we could stick with this. Like everything will work, I believe. So what is sec theta the same as?
1 over cos theta.
Yeah. And then you could just try expanding the brackets, or you could try like adding the fractions first. Like it'll work out, I believe, whatever way you go about it.
And then now that we've done that, and could I just now do I now need to times hmm.
Let's add the two fractions. Yeah.
So I need to get the common denominator. So do I need to times cos theta by cos theta?
Yeah.
And now become 1 plus cos theta squared over cos theta times by 1 minus cos theta squared over cos theta. And then now, do I now need to change everything to sine or something? Or
You could.
so do I need to change cos theta into 1 minus sine squared theta? Or
Yeah, we could do that. Yeah. So that's 1 minus sine squared theta.
and over 1 minus sine squared theta?
That would be if it was
Sorry,
cos squared.
Yeah. And times by sine squared theta.
Yeah.
And so that will become 2 minus sine to the power of 4 theta.
2 minus 4. Oops, sine to the 4 theta over
Cos theta squared.
Okay.
So where did you get the 4 for the front of the sine?
It's a mistake, that's where. Yeah.
Do I now need to do now it'll become 2 minus sine 4 theta over 1 minus sine squared theta.
Okay.
And then
Not sure how else we can torture this thing. I do have an idea though.
Okay.
Another way to do these is to go from the right side to the left side. That's a perfectly valid way of going about it. And maybe it's easier because it's multiplying.
Yeah.
So let's try that way.
Oh, so you can actually start from sine squared theta 1 plus sec squared theta to get to sec squared theta minus cos squared theta.
Yes, they didn't used to allow it. And another stuff they usually don't, but you're allowed to do that. So you say right hand side is that plus 1. And at the very end, we'll get the left hand side, and then we'll just say is equal to left hand side.
Okay, so sine squared theta, and then 1 plus 1 over cos squared theta. And then should I now expand the brackets?
Yeah, let's go for it.
So that'll be equals to sine squared theta plus sine squared theta over cos squared theta.
Yeah.
And
Sine over cos.
I know that's tan squared theta.
Yeah. Let me just see. Tan squared theta. Let's use our thing up here. What is tan?
So will that be 1 over cos squared theta minus 1?
Yeah, I'm just going to leave it as sec squared theta minus 1 for the moment. So I'm seeing sine, I'm seeing sec, I'm seeing a 1.
And
so there's just so many different ways of writing the same thing.
can I now change sine squared theta to 1 minus cos squared theta?
Yes, yes, that's it. So that is equal to 1 minus cos squared theta. Yeah.
And then that'll become, I think that'll just become 1 minus, so that'll become 2.
I think it becomes 0, doesn't it? 1 and minus 1.
Oh yeah, and then it becomes sec squared theta minus cos squared theta.
Ah, yes, and that's what we wanted.
Yeah.
Squared theta, and that's equal to the left hand side. Phew, there we go. And let me just check. So they snaked us. They started with the right hand side for the second one as well. Okay, so maybe it's easier to start with the left hand side if it's not a fraction. It's easier to start with the right hand side if it's multiplying instead of factorizing. Okay. Any questions about that stuff?
No.
Yep, no part of these is obvious. It's a solving equation thing. We'll get there, we'll get there. Maybe. Maybe. Is equal to P. If we have to, we have to. Okay. Yes. I believe. Maybe I'm wrong. Let me just take one last look. So that's just solving. No two ways about that. That's solving, I think, will be fine. All right, we'll do. I have no idea. Right, we'll just do the solving stuff. I think it's time to do all the solving. So I'll just go back to where we were before. Oh, I moved it forward. I hope. Yes. Okay. Now we do all our solving. Okay, how do we solve these?
So
And I can give you a kind of quick thing. Let's say if cosec theta is equal to 4 over 3, then sine theta is equal to 3 over 4 because they're reciprocals.
okay.
And so that's just a quick way so you don't have to do cross multiplying and stuff. Okay, so how do we do A?
So
I just want to see something for a sec, sorry. Yeah, I just couldn't hear myself. Okay.
So would sec theta be equals to? Does that mean that cos theta is equals to 1 over minus 2.5?
Yep.
And then I just do cos minus 1 of that.
Yep.
And that is equals to 1.98.
They have it in degrees.
Oh, right. So I got 113.6.
So let's say 114.
Yeah. And then do I now need to do like 180 minus 114?
That would be if we did arc sine.
Oh, is it 360?
Yeah.
So will it be, and that'll be 246.
246. That looks good. Okay. B.
So that'll be tan t theta is equals to 1 over 0.6.
Well done.
And so do I now need to do tan minus 1 of 1 over 0.6 divided by 2?
Okay. What would you get?
You would get sure. You get 29.5. And do I need to do like 180 minus 29.5?
So two things. With tan, it is 180 plus. And second thing is the graph has been stretched theta direction, scale factor a half. What you should do to make your life easy, let 2 theta be equal to
A.
a. And so don't divide your answer by 2.
Yeah.
And so just do arctan 1 over 0.6. And let's keep it to 5 sig fig.
Yeah. Shall I do that again then?
Yeah.
So that would be so A is equals to 59.
Exactly, or
Yeah, it's 59.03.
what would be 5 sig fig?
59.036.
Yep. And now you can find a second answer using normal method.
And do I now need to do 180 plus 59.036?
Yeah.
Sorry, do you know the answer button is on the calculator where you can like press and?
Graphical, is it?
Yeah.
I think it's like shift something. Hang on a second. View. Calc keys.
Yeah, I found it. Yeah. True.
Yeah. So shift and then the thing next to execute. Yeah.
Cheers. I got 239.04.
And okay, one more thing though. So this was 2 theta. Our interval was for theta. What will be the interval for 2 theta?
0 to theta to 720.
Yes. And so, how do we get more answers?
By adding more 59.03s.
Yep.
And so
Hang on. How did you get your second answer?
I did 180 plus 59.036.
And so your third answer is the same for all of them. It would be third and fourth. Every additional answer would just be previous answers plus 360.
Okay. So do I need to add the 59.036?
Yeah, so it would be first plus or minus 360, whichever way you need, and second plus or minus 360.
So now I need to do 59.036 plus 360.
Yep.
And so and that is equals to 419.036.
Yep.
And do I need to do 360 minus 50? Oh no, I've already. Do I need to do 360 now minus 559.036?
It would be the 59 minus 360, not
Oh,
360
right.
minus. But that would bring it into that would make it a negative number, and it said 2 theta is between 0 and 720. So it'll be correct, but they've just limited it.
So should I do 360 minus 239.036?
Answer minus 360 is not the same as 360 minus answer. 360 is second.
So it would be the second answer plus 360.
Yeah.
And so I got 599.036.
36. And are there any more solutions? You could try 419 plus 360 and see if it's bigger or smaller than 720.
Yeah. So do I need to do 419.036 plus 59.036?
No, plus 360.
Yeah.
Repeats every 360.
And that is, it's over 720.
Okay, so it'll be correct. It'll be the same, but it's outside of the range that we need. And so we had 4 solutions. Is that it?
No, because I need to divide all those solutions by 2.
Yes, well done.
So that would be 29.518.
And we can do them to 3 sig fig now.
So 29.5.
Yeah, and so that was the first one you had at the very beginning.
Uh, 119.52.
Yeah.
Oh, sorry. 120, sorry.
Okay, yeah, 120.
And 210.
Mm-hmm.
And 300.
That's good. That's it. And so those are our solutions. And so your first answer is always, you'll always get it correct. Even with a mistaken method, it's just that if you did plus 180, your second answer would be too big. And it's because the graph has been like shrunk by a scale factor half theta direction. And so essentially it's repeating every 90 degrees because it's a tan graph. It's kind of a special thing. But I won't go into it too much. If it's like anything theta other than 1, just let it be equal to a, solve as normal, and then undo it at the end. For tan, the second answer is 180 plus first, and then the third and fourth answers, any additional answers, are always the first and second plus or minus 360. That's true for sine, cos, and tan. All 3 graphs repeat every 360. Tan also repeats every 180, but let's just use one method for everything. Any questions there?
No.
Okay, and there's the solutions. Okay, exam question.
So there'll be 3. So 3 sine x equals to 8 cos squared x over sine squared.
Not squared, just
Oh yeah, sorry.
over sine x. Okay.
And then should I now do 3 sine squared x equals to 8 cos x?
8 cos x. Yep.
So I change it to 3 minus 3 cos squared x equals to 8 cos x.
Yeah. Uh-huh.
And then maybe do 3 equals to 8 cos x plus 3 cos squared x.
Maybe it's a quadratic.
And so I should then do minus 8 cos x, and then do let a be equals to cos x.
If you like, yeah. Let a be equal to cos x. Okay.
And so would it become minus 3a squared minus 8a plus 3?
Yep.
And then I put into my calculator.
Okay, that's good.
So would the first one would be 1. Oh, should I actually say the answer?
Let's just say a equals or whatever.
A third.
Mm-hmm.
And minus 3.
Okay.
And so do I now need to do so a equals a third or minus 3, and then this be between 2 pi. So and 2 pi is the same as 180
360.
or 360. Sorry. So do I now need to do something with? Or do I need to first of all do arc cos of a third and minus 3?
Yeah.
And so that would be, so arc cos of a third is 70.529.
Back to radians, unfortunately. They have it as pi.
All right, sorry. So cos will be, or the third will be 1.231, and then arc cos of, yeah, there's no such thing as arc cos of minus 3
Any idea why?
because it only ranges from 0 to 1 or something. Oh no, minus 1 to 1.
Yeah, so it's outside of the range. And is that full marks?
I'm guessing I now need to do. So we're doing cos. Is that 2 pi minus 1.321?
Very good.
So is that 4.962?
So I'll just round it. 4.96 and 1.23. 1.23, 5.05. What did you put in 2 pi?
I put in 2 pi minus the wrong answer. Sorry.
Okay.
Yeah, I got 5.05. Yeah.
Okay. That's great. 5.05. I think you did great.
Cheers.
I find these very difficult, but yeah, you change sine squared x into 1 minus cos squared x, and then it's a quadratic, and then you just go for it. Okay. This thing, what is this about? Hang on, before we do this, I just want to keep to this weird stuff. Okay, how about this? I already regret skipping that previous one. 8 marks.
So that will be 1 plus 1 over, oh no, 1 plus cos over tan x, no, cos over sin x
Mm-hmm.
over 1 plus sine over cos x.
And you know I don't deal well with quadruple fractions, so I'll just do it like that. 1 plus sine of x cos x. So let's write it as divided by instead.
And so should I now do times the ones from both sides? So the first one by sine x,
Uh-huh.
and that'll end up being sine x plus cos x over sine x.
Yeah.
Divided by cos x plus sine x over cos x.
X plus sine x over cos x. Yep.
And then should I then times, this might be a bit weird, should I then times both of those sides again? So the first side by cos x and the second side by sine x.
How do you divide fractions?
Keep, change, flip.
Just keep it simple. Okay.
That'll be times by cos x over cos x plus sine x.
Okay.
And that'll be equals to sine x cos x plus cos x squared.
Slow down. So you could do it there or without expanding anything.
Yeah.
Why didn't I expand it?
Because there's a tan x, or could the cotan x.
Yeah. And so what would you get?
You'd get cotan x, sine x plus cos x over cos x plus sine x.
What do you know about sine x plus cos x and cos x plus sine x?
It's the same. Oh, so it would just become tan x plus 1, or even just tan x.
Or even just cotan x, like you said the first time.
Yeah.
Tricky. So that made our lives much easier. So that's cot x. That whole thing is cot x as equal to 5.
So now we know that cot x is cos x over sine x. Do I now need to just do like 1 over? Should I change cot x to cos x over sine x?
I would instead change it to, if cot x is equal to 5 over 1, then tan x is equal to?
A fifth.
Yeah.
And then now I need to do, yeah. And this is in degrees this time, isn't it?
Yep. They don't like to give us any momentum.
So I got 11.3.
Second answer?
And that would be 191.3.
That's great. So x equals 11.3, 191.3. Fingers crossed. Yeah, that's the wrong answer. I need to fix those. But this is answer from somewhere else in the book.
Yeah.
It's the wrong chapter. My mistake. I need to fix it. But it looks good to me. Okay. Wow. So to avoid fractions of fractions, I write them separately as divided. Add the fractions. Keep, change, flip. Algebraic fractions fully factorize so that you can cancel down. And then to solve a reciprocal, just do the reciprocal literally. Let me now do something that I never want to see you try. So cot x is 1 over tan x, and that's over 1 plus tan x. The whole thing is equal to 5. So because there's no 2x and stuff, this could work. Let's say lucky 7. 11.3, that's what we said. So we got very lucky. And then I know from my knowledge that the tan graph actually repeats every 180 as well as every 360. And so that's tan and that's tan. And so I would just do my answer plus 180 and I'd get the same as that. Okay, if you're in a real pinch, you could do something like that. Let's just try to avoid it. Is it time for this thing yet? Might just be. No. Maybe. I think it's time for this thing now. And I'll paste. I need to get that thing back again. Our identities. Copy. Okay, let's try this one.
I'm guessing I'm not allowed to use the calculator here.
You can always use calculator. Just be aware that I'll beat you if you do. So the reason why is you'll get half of the answers, but you won't get the other half. I'm just able to recognize in that previous question there's nothing squared. It's tan and tan, cotan, tan, and so it'll all work out. This one,
yeah,
no, it's not too bad though. It's not as bad as it looks.
So should I do 4 times 1 minus, or even just 4 over sine squared theta?
Could work. Yeah, 4 over sine squared theta minus 9. And that will be equal to... it'll work. Okay. Yeah, go for it.
Yeah, so 4 over sine squared theta minus 9 equals to cos over sine theta.
Okay.
And then probably expand the brackets. No, nobody expand the brackets. Just times both sides by sine theta.
Yeah. What do you get?
You get 4 sine theta over sine squared theta minus 9 sine theta equals to cos theta.
And then? These will cancel.
So it would become 4 over sine theta minus 9 sine.
It's kind of just going in circles a bit.
Yeah.
I was wrong. It's not easy. Let us use our identities. Anything we can do there?
So we could do 1 plus. So we could do 4 times 1 plus 1 over sine squared theta.
I'm just going to leave it as cot for the moment.
Yeah. And that would, yeah. And that would be equals to 4 plus, should I say like 4 cos theta over sine theta, or
Leaving it as cot for now. What is next?
Oh. So if you simplify, you'll simplify it, then you have to do like let cot theta be equals to a.
Yeah.
And then that will be equals to, so 4 cot squared theta minus, sorry, yeah, 4 a squared minus cot minus a minus 5.
Yeah.
And so I got that a is equals to 5 over 4 and a equals to minus 1.
Okay.
And we're dealing with, do I now need to do like theta? Do I now need to do like cot theta equals to 5 over 4?
Yep.
And that just means 1 over tan equals to 5 over, that would just be like tan theta equals to 4 over 5.
Mm-hmm.
And so it would be arctan of 4 over 5.
Mm-hmm.
And that would be equals to 38.7.
38.7 was it?
Yeah.
Okay.
Or would it be, would minus, is the flip of minus 1 just minus 1?
Yeah.
So that would be arctan of minus 1, which is it said the answer is minus 45, so I can't do that, can I?
Don't discard it just yet. How do you get second answers?
I do 180 plus or minus. 180 plus, I think.
180 plus.
That would be 180 plus 38.7, which is 218.7.
7. Okay.
And then 180 plus minus 45 would be like 135.
135. Yep.
So those are my answers.
The minus 45 is outside the range, and so how could we get a fourth answer? You got that third answer, 135, using minus 45. How else can you get an additional answer using that minus 45?
Would I add minus 45 to that answer?
No one has ever said anything like that to you. Fourth answer is second plus or minus 360, depending on which way you want to go.
So,
And sorry, Any additional answers are also first plus or minus 360.
So should I do 218.7
That'll be
minus
that'll be
minus 45?
that'll be way no. Andrey. First answer plus or minus 360.
Oh, right.
Your arctan answer plus or minus 360.
So that would be minus 45 plus 360.
Yes.
And that would be 315.
And that will be 315. And so those are our four answers. 38.7, 218.7. Wow. 135, 315, 38.7, and they put it down to 219. Let's see. Let me see. So we would have gotten two answers. We would have gotten arctan and then 180 plus. But because it's a quadratic, we got four answers. To your arctan, to your initial answers, you can just do it's the same thing. I just haven't figured out a good way to phrase it. I have to come up with a better way to phrase it. But and I'll just I might regret telling you this, but tan repeats every 180, unlike sine and cos. And so all your previous answers you can just keep adding 180. In the same way with sine and cos, you can just keep adding 360. So 135 plus 180 is the same as minus 45 plus 360. They'll both give you 315. Tan is kind of special like that. Whew. Any questions there?
No.
Okay, so let me see. And there's one last little thing that we haven't gotten to for these, but we'll get there. And so the stuff that we did, x a half or tick.
I think I'll give it a tick.
Yeah, the first student I've ever had who's given himself a tick for this trig stuff. I'm happy. Yeah. How was that for you, Andrey?
That's good, thank you.
This is going so well. I'm not even telling you. I've really struggled with teaching this stuff. It's real tricky. No one gets it. But let's see. Yes. What else? So inverse trig, we don't need to worry about that just yet. So we did all the proving, as far as I'm aware. And now we just need to use it. Now we're doing all the solving. We have a bit more. And then after that, it's inverse. Yes. Any questions for... So do we finish this stuff next time?
Yes, please, yeah.
Okay. Yeah, worked out well. Any questions for me in general?
I don't think so.
Okay. Well done, Andrey. You're doing great. I look forward to talking again next week.
Okay, thank you. Bye.
Have a good weekend. Goodbye.